So we will look at two example questions now. The first example is find the Taylor series for fx equals to 1 over x squared about x equals to -1. So now first we have to evaluate all derivatives. So the original one is already given, and here I'm writing it into another form which is easier for us to see. So which is x negative squared. And then the next one is the derivative of x negative squared, which is -2x to a negative cubed. And then the next one is 6x to the negative power of 4. And all the way down, the next one is the derivative of the previous one, which is -24x to the negative power of -5. And then the fourth one is the derivative of the previous one as well, which is 120x to the power of -6. So now we can write it into -2 times -3 x to the power of 4. And by writing these down, we will find a pattern as the derivative evaluation goes on. So now we kept writing it, and after we finished at the last example that we provide, we can now find that all these patterns it's a factorial problem. So for example, now is 3 factorial x to the power of 4, and the next one start with -4 factorial x to the power of 5. And for the fifth term, which is f to the prime 4x equals to -5 factorial x to the power of 6. So these are a pattern that we found from the derivative evaluation. So now we can find out the formula by evaluating the derivatives and finding the patterns. So the formula starts with -1 to the power of n times bracket n plus 1 bracket factorial times x to the negative power of n plus 2 equals to f prime n x. So now we found out that f to the nth term of x equals to can be evaluated through this formula. So now we substitute the terms back into the formula we found. So here we start with -1, which is equal to n plus 1 factorial times -1 times to the power of n plus 2 times -1 to the power of n. And we can further write it into n plus 1 factorial times -1 to the power of -n plus 2 plus n. Here we add the power together, so the next step we can write it in as n plus 1 factorial times -1 to the power of -n minus 2 plus 9. And this then can be written into n plus 2 factorial times -1 to the power of -2 equals to n plus 1 factorial in a fraction form, which is 1 over -1 squared. And then the next step is n plus 1 factorial 1 over 1, which is 1. So the final answer is n plus 1 factorial. So now we can get Taylor series for this function. So first of all, we write down the Taylor series original formula here. So the Taylor series formula is fx equal to sigma n to infinite equal to 0 f to the power of n times a over n times x minus a to the power of n. Now we can substitute our answers back into the formula, which equals to sigma n to infinity equals to 0 f to the term of n times negative 1, which is substitute a, over n factorial times x plus 1 to the power of n. And then we can write it as m plus 1 factorial over n factorial times x plus 1 to the power of n. And then we can eliminate the factorial, and then write it into m plus 1 bracket over 1 times x plus 1 to the power of n. And the final step is sigma n to infinity equals to 0 times m plus 1 times x plus 1 to the power of n.